What is the difference, first of all, between factor and zero?
Factor, you're figuring out the number that goes into it. But when you're finding the zero, you find where it hits the x-axis.
So a zero is like where it hits the x-axis. So if I'm asking is 2 a 0, I'm saying does the graph hit the x-axis at 2? That's one way of thinking about it. When I say a factor, I might have asked the same question, but said like is x minus 2 a factor of this polynomial? So that's the same thing. Factor includes the x with it, and 0 is just the number. But saying is x minus 2 a factor is the same as saying is 2 a 0. How do we decide it? There's two ways. What's one option to figure out if it's a 0? Plug in 2. And what should you get out? 0. The remainder theorem tells us if we plug this in, it's essentially just going to give us the remainder if we were to do the division. And we know that if it's a 0, your remainder should be 0. If you get any other number, it's not. So we could find p of 2. So that would give me 8 minus 8 plus 18 minus 10, which is 8. So is it a 0?
No.
No. Did I do my math right? No, hold on. I have a mistake, don't I? Yes, hold on. This should be a 16. 2 squared is 4 times 4 is 16. So it would be negative 8 plus 8, which is 0. So is it a 0?
Yeah, I was just saying, I graphed it and it hit it too.
See, just checking to see if you guys are paying attention on a Monday morning. You all failed. Nobody argued with me. But
I had already for you guys that this one would be correct though.
you
Yeah, he said
did,
yes
you
to
did. So what would have been the other way of deciding this?
Synthetic division.
Synthetic division with the 2 out in the box, and then you just list the remainder. It should have been 0. All right, so B, to check the negative 2, we just plug in negative 2. And we get, let's see, negative 8, so be negative 12, minus 4, minus 3, so negative 19. So is that one a 0? No. That means if you did the long division, your remainder turned out to be negative 19, so it definitely does not work. All right, so that's just kind of a refresher of where we ended on Friday. Are there any questions there? Okay. And then let's look at a problem. So we're going to do several different things with this polynomial. And I want to kind of draw some connections with this example. So the first thing I want you to do is graph this polynomial and find your zeros from the graph. When I'm asking for zeros, what am I asking for on your graph?
Where it hits the x-axis.
Right, x-intercepts, where it hits the x-axis. Right, so when I ask for zeros, those are just your x values, so it's just a number. So where does this graph appear to hit the x-axis?
Negative 2.
So we do have to kind of estimate there a little bit, but it seems fairly accurate. Okay, so if I said find the solutions to p of x equals 0, what does that mean?
Factor it out.
Is that equal to 0 or plug in?
I'm saying what x values make this equal 0? Can you tell me what they are? Yeah, it's the same question, just phrased a different way. Zeros are the same thing as the x's that make y equal 0. Okay, if I asked for factors, if negative 2 is a 0, the factor has x with it, what would that be? I need to know what the factor would be. So factor has x, and negative 2 makes it equal 0.
So x plus 2,
Mm-hmm.
3x plus 2, and
Mm-hmm.
then x minus 1.
So it's always the opposite of these. Negative 2, if you put that into x plus 2, it equals 0. If you put 1 into x minus 1, it equals 0. The fraction, let's look at that. Did we write that one correctly?
Oh, wait.
Yeah. You could think of it if you do x plus 3 halves, and then we went to get rid of the fraction. So if you multiply by 2, it should be 2x plus 3. We just flip those. All right, so everyone understands the difference between the factors and the zeros? So if I want the factored form, that's just when you multiply those things together. So it's just x plus 2 times 2x plus 3 times x minus 1. We just used the graph to factor that polynomial, kind of like we did on one of our assignments last week. We had a couple questions. Okay, then we answered questions like this back when we were dealing with quadratics. So now let's apply it to this problem. I want to know when this polynomial is greater than 0. We have a graph. When is it above the x-axis?
Between negative 2 and negative 3 halves.
Mm-hmm.
And then from 1 to infinity.
Good. It's kind of hard to tell that one, but it is in between there. So because it didn't have an equal to, we'll do parentheses, negative 2 to negative 3 halves. Union 1 to infinity. And where is it less than 0?
Infinity.
Mm-hmm. There's 2 of them. Negative 3 halves to 1 is one time when it is below the x-axis. When's the other time? Mm-hmm. Negative infinity to negative 2. Any questions there? So the rest of the day, what we're going to do is factor zeros, or factor polynomials, but I am going to give you a starting point. So eventually, probably not until the beginning of next week, we will be able to factor these without having the starting point, but I am going to give you a hint. I'm giving you the first 0 of this polynomial. And we are going to use that 0 to factor it. So think about, like, if you are factoring, let's just go way back in the day. If you had, let's say 24. Okay. And I told you I wanted you to make the prime factorization. Do you guys remember kind of making factor trees and breaking that down? And you would say, well, 3 times 8 is 24, right? 3 we can't break down, but 8 we could keep breaking down, and you would have to keep going. So essentially, once you had the first number, if I knew 3, how did we get 8? Divided. 24 divided by 3 is 8. So if I give you the first one, we're going to start by dividing. So if 5 is a 0, we can divide this polynomial with the 5. We're just going to do synthetic division. So 6 comes down, those multiply to 30, add to -7, multiply -5, add to -3, multiply -15, and we know that has to be a 0 there because I already told you it was a 0. So if you get some other number for your remainder, what does that tell you? You messed up, okay? Fix it. Don't just pretend it's a 0 and go on with your life. Find where you made a mistake. So this is my remainder, my constant, my x, and my x squared. So now this problem is 6x squared minus 7x minus 3. Okay, so if we were actually like factoring with numbers, when we get to this 8, we would break it down, right? And we would say, okay, well, 8 is 2 times 4. So we have to keep breaking it down. What do you notice, though? If it's an x squared, what can we do to break that down? Slip and slide. So we took a polynomial that we couldn't factor with any means we knew, but I gave you the first 0, so we divided it, and now we have something we can work with. So if I did slip and slide, multiply to -18, add to -7. Divide by 6. So 9 over 6 reduces to 3 over 2. 2 over 6 is 1 over 3. My directions were to factor this polynomial. It is partially factored right now. Yes. It was an x to the 3rd. So we need degree 3. Currently, if I FOIL this, it's only 2. I need one more parenthesis. But that's where the other 0 comes in. If 5 is a 0, then my factor is x minus 5. And if you multiplied that out, you would get your original problem back. I want you guys to try it. So see if you can factor this whole thing if -3 is a 0. That helps. I was just thinking this is not going to work.
She's paying attention.
Yeah, I had to pay attention. I can't post too. I had correct.
You do whatever. I think we got
So
it
I
right.
write damage.
Alright, so you got a 2x plus 1, a 3x minus 1, and what else do we have to put in there?
X plus 3.
Okay. Did you guys get it?
I'm so sorry.
So, similar question, but I'm changing my directions. I'm asking you to find the remaining zeros. So what are zeros? Where it hits the x-axis. So it's just a number. So we're doing the exact same thing, except I don't want the factors at the end, I want the zeros. So where do we begin? 3, 2. What multiplies to 2 and adds to 2? Nothing. So what else can I do to solve this? Right, we can't factor it nicely, but I'm not even looking for the factors. I just want the zeros or the solutions so we can do the quadratic formula. So opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Right, what is the square root of negative 4?
2.
So we get negative 1 plus or minus I. Okay, my question was remaining zeros. So do I have to list the 3 again? No, I didn't say tell me all the zeros. I said tell me the rest of them. So these are the other 2. Negative 1 plus I and negative 1 minus I. So same process, you just have to watch the question at the end. What if I said find all the zeros? Then you would write the negative 3 down as well. So you just have to watch, am I asking for factors, all zeros, or remaining zeros? You guys do this one for me. Okay, so if we set up slip and slide, we get x squared plus x minus 30, which factors into x plus 6, x minus 5. Divide by 2, so that's x plus 3, 2x minus 5. But the question was, give me not the factors, the remaining zeros. Since it's remaining, I don't have to use the original one given. So you set x plus 3 equals 0, you get negative 3. If you set 2x minus 5 equals 0, you get 5 halves. Are those okay? The last one I want to look at. Last one, last type. We'll do one. If we need a second one, I've got another one. So, isn't it beautiful? I'm asking you to factor, and I've given you the first 0, so same thing we have been doing, except, what do you notice about this polynomial?
It has eyes.
It has eyes in it. It was not a polynomial with just real number coefficients. We have some imaginaries. my coefficients, it's a 1x cubed. My x squared coefficient is 7 minus 3i. My x coefficient is 12 minus 21i. And my constant is negative 36i. And we know when we do this, we should get a remainder of 0. So 1 comes down. 1 times 3i is 3i. Add and we just get 7. 7 times 3i is 21i. Add, and we get 12. 12 times 3i is 36i. Add, and we get 0.
This sounds awesome.
Yeah, it's not bad at all. The i's cancel out. Just looks scary to start with. Alright, so then we have x squared plus 7x plus 12. That factors into x plus 3, x plus 4. I did ask for the factored form this time, so I want these factors, but I need one more. What would the last one be?
X minus
One more?
I thought you
Oh,
there was
no,
one
there's
more
not one
X.
more
Like,
principal.
wait, what?
I meant, let's do one more problem.
That's scared me for a minute.
Second grade, we would have cried some of this.
You know what my first grade daughter has been doing? She found a pre-calculus textbook at home, and she's been copying problems down all weekend.
She got that right.
She doesn't really know what they mean. Like, I started explaining some to her, but negative numbers really threw her, because we haven't ever talked about anything like that. So, you know, if it's just basic addition and subtraction, she's good, but if you subtract and get a negative, that just kind of blew her mind.
But you can't have more than 0.
Yeah.
Less than 0. But have you heard of the sine and a cosine?
So we put the 1 plus I out here. My coefficients are 2, 3 minus 2i, negative 8 minus 5i, and 3 plus 3i. So 2 comes down. What do we have to do to multiply those? Yes. So 2 times 1 is 2, plus 2 times I is 2i. And we get 5.
Oh, okay, that's what I want.
5 times 1 is 5, plus 5 times I is 5. And we get negative 3 times 1, plus negative 3 times I. It's all cancel, we get 0. And you're left with quadratic, so you just simplify. The one thing we need to be just slightly careful on, we always do x minus our 0, right? So if you do x minus 1 plus I, that turns into x minus 1 minus I. You'd have to take the negative to both terms.